cleansing the data. But understanding and interpreting data is just as critical, just as critical. I'd meant to put up a graph there just to illustrate a funny point. I forgot to do it, but I'll talk you through it. But sometimes correlation, which means two variables seem to be connected, does not necessarily mean causation. It does not mean that one variable causes the output or change of another variable. And that's something that's very, very difficult to do. So for example, if you look at, let's take shark attacks, okay? Shark attacks and the consumption of ice cream are highly, highly correlated. Can anybody tell me why?
That's an interesting one.
You eat ice cream at the beach and you end up dead because the shark ate you.
Close, carry on. Think about it. Shark attacks and ice cream. Let's unpack it. When do people usually swim?
In summer.
When do people usually eat ice cream?
In summer.
In summer.
There's coloration there.
That's correct. So, okay, so there was what's called an unobserved variable. The unobserved variable was summer. But because we didn't look at that, we looked at ice cream and we looked at shark attacks. Now, someone without data training would have assumed that eating more ice cream makes you more likely to actually be attacked by a shark, irrespective of if that person lives in the middle of Gauteng. You know, you can make those kind of spurious kind of interpretations of data, and that's just a silly example, but just to give you an indication, all right, that data can also be very misleading. So it's very important not to make assumptions about correlation and to truly understand relationships between variables. Okay, right.